Hello, everyone. Welcome back to SAT Math Question of the Day. Here we have our question of the day. Please try it, pause it, come back, and we will try to go over it. Okay, which of the following expressions is equivalent to the given expression? And this is obviously operations of polynomials. So we have to do, some teachers don't like to call foiling, but...
Okay, I will start by by explaining how one could see and pick the choice very quickly.
Okay, go ahead.
You scan these four choices and
Right.
notice that all of them have a non-zero constant term.
Right.
And this is the only one that uh, uh, don't have
Right. So Seth's looking for patterns.
don't have
Right.
a non-zero constant. Now you look at here. This has a non-zero constant. One factor has a non-zero constant, but the other factor does not.
Yeah.
The other factor can be factored as 5 plus a third d times d.
Right.
Okay?
Yeah.
In other words, whatever the answer is, it must be a multiple of d. And therefore, d is the variable, it's not the constant, so it must have it must have no constant term.
Right.
Therefore, this is the only choice that matches. And then we make the assumption, which is valid when you're taking the SAT. It's not valid anywhere else that the true a correct solution is always one of the choices on the SAT. Using that assumption, we pick D, and I bet that's going to be what they pick also.
Right. So
now you could go on and explain for the benefit of audience members who didn't understand what I said. And though if you don't understand what I said, listen to Joel, and then you will understand it.
Okay, well, first of all, I also would have used patterns to help me. I would have noticed that the answer has to have a d cubed. See, the d times the d cubed is going to be...
I looked at that too. I looked at that too originally, but I noticed that these two have d squares, and all of them, and three of them have three of them have d squares, and two of them have d's.
Okay.
So that pattern is too broad to help with this question.
Okay.
Certainly look at patterns. Yeah. In fact, when I looked at it, that was the highest power was the first I looked at, and then I noticed that two of them had a high power of d. So I said, okay, let's look at something else. And then I noticed that only C had. Then I looked up here and I saw that the second factor was a non-constant. And then I noticed all these twos on top of each other. And that was the pattern that happens in this problem to uniquely determine the answer.
That's
but
really
patterns are great, yes.
Okay, Seth, calm down. Okay, so what I would have probably have done, but Seth swooped in and did it, is I would have noticed that there's a d cube's got to be part of the answer. So I immediately would have rejected these two. Then I would have looked at these and said, and then I don't know what I would have done. I probably would have noticed that there's a common d here, and I would have done what Seth did. I would have factored the greatest common factor out of this. So I would have done d, 5 plus 1/3 d squared like Seth did. Oh, look at this. Seth made a mistake. Oops, too bad. Right? No, not d. Wait. No, I'm wrong. Sorry, take it back. I'm wrong. So then I would have probably have factored this probably in my head and then noticed, I would have noticed there's a D sitting here, and then I probably would have noticed that, but I don't know. I mean, it's possible.
Well, I wrote this factorization because I wanted to show our audience what I said.
Yeah.
But what I noticed was that this term had a factor of D, and I did not calculate or think about what the other factor was.
Right. Yeah, you
when
don't have
I
to waste your time.
made the conclusion.
Right.
But what I did here was show everybody the way it factors by showing the other factor.
Right.
In other words, I did not think of this expression when I continued my reasoning to pick the answer.
Right. So all Seth is saying is that when you factor this and pull out the D, you have, let's say, the circle term, which we'll call the circle term. You have the plus sign term. You have this plus sign term, and you have a D, which is this D, which means the answer has to have every term in the answer's got to have a D in it. And these are the only two choices.
Divided by D.
This doesn't have a D. This only has a 2, so this has to be the only answer. Again, we're taking advantage of patterns as opposed to just brute force multiplying it out, which one would do, one can do, but one also loses time doing it. So you want to try to look for patterns. Now, for the people who don't see the pattern, let's just multiply it out. And maybe we don't have to finish multiplying it out. Maybe we can multiply it out enough and then notice that, there's going to be a something we can pick up on. So if you do 2 plus 1/3 D, this is that foiling thing, 5D plus 1/3 D squared. If you do it traditionally, you get a 10D. Now I would stop here and I would say, well, okay, there's a 10D. Is there any other way to get a D? There's no other way to get a D term, right? Because D times D is D squared. D times D squared is D cubed. 2 times 1/3 D squared is not D. So look at this. The only D term you get in this term is a 10D. So you look at the answer and say this has got to be the answer.
Well, when you carried out the so-called foiling, what you did was a thing that I think people are observed to do naturally, and what people often do because they're shown this in they look at polynomials, they see the polynomial where the terms are written in increasing degree from left to right. So the smallest degree terms are on the left.
Yeah.
The product of these two terms is 10D. It is the term with smallest degree.
Of D, yeah.
Yes, the smallest degree in D. Of course, it's in term in D because there's a single variable. There's only one variable that has power. As you take powers of. So the degrees is only one variable for degree, and then you could see that the answers are written in left to right, increasing degrees. So the leftmost term is the term of lowest degree. And the lowest degree in here, which is the term of lowest degree is 10D, matches the term of lowest degree here. Therefore, and it doesn't match the term of lowest degree in any of the other choices. Right. So that uniquely leads you to the answer as well.
Right. So in other words,
it's a good idea when you're doing foiling. Suppose you have this. Suppose you're given this.
Let's make some space.
X
Wait,
plus
let's
3.
make some space over here.
Okay. Suppose you give him this question: X plus 3 times 7 plus 2x.
Yeah.
Foiling would tell you, outside, inside, outside. This guy. Nah, no, don't do it that way. Do the picking in terms of order of degree, and you have your choice. You could, one choice is to put the higher degrees first, and write this is x plus 3 times 2x plus 7, or you could do it by do it in order of increasing. Put the lower degrees first. Okay? And that way you could work in order to pick out the terms of different degrees.
Yeah, right.
Yeah. Well, so I would think in SAT questions they would give you problems in this form where the factors are not all written in the same term order.
Right. So this question.
Well, they might. I think what is silly but common is that they'll mix up. They'll change the term order when they want to put a negative sign in front of a higher order term.
Right.
When it's added with a lower order term with positive sign, so they don't write it as minus x plus 7. But some people think that's ugly.
Yeah.
But I don't think, that's not ugly.
No, if I saw minus x plus 7, if I saw this, what I would do was I would factor out a -1, and I would do x minus 7, and I would put the -1 in the front.
Yeah.
Right? I would put the -1 in the front, -1, because this is very nice. It's very nice to have that, and this is a little confused. This is negative x plus 7. That's a little funky. So I would make it.
Well, the nicest form for polynomials is what's called the monic. It's called the monic form. That is where the highest order term has a coefficient of 1.
Yeah, right.
Highest order has a coefficient of 1, except in one case. Except when the polynomial equals 0. But if the highest order coefficient of your polynomial is not 1, then you could put it in monic form by factoring the highest order coefficient out of every term. So in monic form, the highest order coefficient is 1, and then the highest order term is written first, and the terms get to go to lower degrees as you go from left to right.
Yeah.
This is the most convenient form when you're doing factoring.
Yeah, right. Of course, right. Yeah. This brings up this little thing here, which you have to look out for. Brings up a little anecdote that I had, where this week someone had a problem like this, where it was x minus 3 squared, and then 3 minus x. Okay? And then the zero is at x equals 3. But it was asked, what is the end behavior?
It's a triple zero.
Yeah, it is triple zero at x. So what is the end behavior? Unfortunately, the teacher forced the kids to memorize the end behavior rule, that if you have a degree of 3 and you have a positive coefficient, which you seem to have, there's a positive number here, then the then right, then it goes like that, right. The only trouble is that this doesn't have a positive coefficient. This has a negative coefficient. This has a negative coefficient.
Yeah.
Right, exactly. But the teacher forced them to memorize the rule that if it's degree 3 positive coefficient, the function has n behavior looks like this. But the person didn't realize that, oh my God, like this is no. This is x minus 3 with a negative sign in front. So it has a negative
the rule says if the degree 3 in a cubic polynomial, if the highest order coefficient is positive, then the asymptotic form is the blue one. There's an if for that. If the leading term is positive.
Yes, of course.
So if the leading term is not positive, the rule it does not apply.
Right. I know.
So that so rules are okay as long as you use the condition.
Yeah.
Check that the condition is true before applying the rule.
I know, but that's not the problem. The problem is
the problem with the student is the student forgot to check and verify the condition is true, and the student applied the rule without checking the condition and got the wrong answer.
Yeah, because the person didn't realize that this is the negative of x minus 3. So that's why
he didn't.
That's why I personally don't like that rule. And let me just give a quick thought as to how I would do it. I hate that rule. What I do...
that's a good rule. No, it's a good rule.
I hate that rule.
Because it's a good rule for me. Because my favorite form for polynomials, the monic form. And the monic form is an even better case of when the highest order coefficient is positive. And so if you immediately put your polynomials in monic form, then the rule applies. In which case, the rule is really cool. If the degree is positive, if the degree is even, it looks something like this.
Okay, enough with the rules.
If the degree is odd, it looks something like that.
Okay, let me show you. I don't like the rule because I don't like to have to memorize rules. So this is how I do it. You want n behavior. You want huge x. So I do the plus negative game. If x
well,
is
that's
huge,
why the rule is true.
I know. If x is big, then this number is positive. In fact, this number is always positive because you can square a number, even a negative, and we get positive. If x is really big, then this term is negative. A negative turns to positive is a negative, which means that for large x, it's down here. Now let's play this game again. For x hugely negative, well, this is always positive. And for x hugely negative, like negative 1,000, this is positive. Positive times positive is positive. So the end behavior is, Seth doesn't like when I go big, but I'm going to do it anyway, is up here. Right. So the thing has to go like this, sort of, like,
Well, it's even true. If instead of 2, it might be 396, which is an even number, and the coefficient, the power for the 3 minus x might be 1,521.
Yeah, which is odd.
Which is an odd number.
Yeah. So you do. I don't know. I don't like the rule. I like to just play the plus negative game, and you just do that for all the factors. Anyway, enough said on this. Let's see how they did it. Did they FOIL it out, multiply it all out, or did they stop at the 10D, which is really sort of like a really good way to do it, because then you don't have to waste your time with anything else. So let's see how they did it. Okay. Sometimes anyway, I don't know what they did. So we will find out. Right? We will find out. My bet is that they will have done the whole problem also because they want to show how to do the whole problem. Okay, so let us see how they did it. Step-by-step solutions. 3 steps. Ouch. 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 Well, first of all, wait. Let's distribute. Okay, so they didn't do foiling. They did double distribution, which is okay.
Hmm.
Uh, and then they literally did everything. Ouch. 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 I mean, you got to know how to do this, but you don't have to do this, and you really spends a lot of time on. Oh my God.
Well,
Wow.
number one, you have to know how to do it.
You have to know how to do this.
Second, when you know how to do it really well, how much you have to do depends on what the question is.
Right. And the answers, because if two answers both had a 10D.
SATs,
Yeah.
The answers are part of the question.
Right. Because it's almost all multiple choice. There's a few short answers, but yeah, almost all multiple choice. Okay, so I think that's it for today. Seth has a PhD in math from MIT. He's a professor emeritus in computer science from SUNY Albany in New York State. And I'm Seth's brother. I have a PhD in math. No, I have a PhD in mechanical engineering. What am I talking about? And we try to offer different approaches on how to do the SAT math questions. And in terms of approaches to study for the math SAT, Khan Academy is great because they give you a nice set of questions, like 600-700 questions for either the digital or the non-digital SAT that you can practice on. And they partner with the College Board. So the questions are sort of sanctioned by, you would think the questions are sanctioned by the College Board, which is the people who make the test. So I guess that's it. Please like us, dislike us, give us comments on our YouTube videos. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. Okay, hope to see you when we meet next, which hopefully will be daily. Take care, everyone.
Okay, goodbye.